All right, using the ANDing chart that's located in Moodle, let's AND network or IP address 198.19.73 and a subnet mask of 255.255.255.240. And the first step requires us to convert the IP address to binary. Okay. Yeah, the first step requires us to convert the IP address to binary. Okay, in order to get 198, I need the 128-bit, the 64-bit. I can't use the 32-bit because that'll be too much, so that'll be 0. 4 and a 2? Okay. All right. Basically, it'll be the same combination for the second octet. All right. How do I get 19? $16, 2, and 1. Okay. All right. What about 73? $64, 8. 64 and 8 will be 72. It's an odd value, so I'll have to use the 1. Is that correct, DJ? Yeah. All right. Okay, now that I have the IP address converted to binary, what's the next step?
Subnet mask, same way.
Convert the subnet mask to binary. Okay.
One across the board. Actually.
One's across the board.
The last one should be 4 ones and 4 zeros. Right?
Okay. Well, I can't do ones across the board in the last octet because I need to create what value? 240, right? Okay. So I need the 128-bit, the 64-bit, that's 192, plus the 32-bit is 224, and the 16-bit. Okay. All right, I've converted the IP address and subnet mask to binary. The next step requires me to do what? Actually, AND, right?
Okay. I didn't even notice that extra space up front.
Okay. So I need to compare the column, or compare the values in the column. Okay, so this will be a 1.
You said if there's a 0, it would end up being 0 no matter what.
Right. 2 1s will equal a 1. Any other combination will be a 0. So what about here? Okay. 0, 0, and when I get here, it'll be 1, 1, 0. All right. So what's the network address? One ninety eight. 198. 1964. All right. You notice I put an extra cell here. That's so we can count up the ones and use what's known as slash notation. So we're going to count up all the ones in the subnet mask portion. It's 28? Okay. Slash 28. Now what does that mean? From time to time you'll see the slash notation used. It conserves space. For example, we can write this IP address or network address as 198.198.64/28. That /28 is the same as writing 255.255.255.240. Because basically all we're doing is counting all the ones used to create the subnet mask. Okay? All right. Here's a little test question for you. What if you saw /24? What would that be if we converted to decimal? Here we converted 255.255.255.240 to slash notation, and we can convert it back to decimal, which will be the 255.255.255.240. What does /24 convert to in terms of decimal?
Does it depend on? Because of course one of the octets is going to be algebra across the board.
Okay.
But which one is going to be algebra?
Let's create it. All right. Whenever you're counting ones in the subnet mask, you always start from left to right with no gaps. So they're going to be consecutive ones. So let's go ahead and express this in terms of decimal. So we'll convert the slash notation to binary. So we need how many ones? 24. Okay, that's 24. 24. And we can write it in decimal, and it will be 255, 255, 255.0.
Then would you put the /24 in?
You wouldn't put the /24 in here because it in essence means /24. Okay. Okay, I'm going to go ahead and give you another little tidbit here. The slash notation or the subnet mask indicate how many bits are used for network, or how many bits are used for the network address. Okay. For example, here we see that we use 28 bits. 28 of the 32 total bits were used for network bits. Okay. 28 of the 32 were used for network bits. Then how many bits are left for host bits? 4. It's 28 of the 32 for network, 4 for host. And then you will probably ask, okay, well, if this network address is 198.198.1964, then how do we know the entire range for that network, right? Okay, if we start at 64, then what we can do next is, remember that there are 4 bits available for hosts. We can do 2 to the 4th power to find out what that range is. What is 2 to the 4th power? 16.
Yeah, I forgot.
16. Okay, so the range is .64 through, if we include 64 as one of the 16 values, 64 through If we include 64 as one of those 16 values, 64 through 79. Okay.
Oh. Okay. Right.
Yeah, the operative term was including the 64 as one of the values. Okay. Okay, now that you have some principles there, let's go to this example, the /24. How many host bits are used or available in this example? 8. We've used 24 for network purposes, and there are 8 bits available for the host. So what would this range be? What would the host range be? 2 to the 8th power gives us a value of 2 to the 8th power. 256. So what would the range be here? It would be 0 through 255. Okay. Remember, the range will always begin on an even value and end on an odd value. Okay. Okay, we have package tracer loaded. All right, I'm going to interface 0/0, and I'm going to this IP address to one of those interfaces. The IP address and the subnet mask. All right, 198.198.19.73, and the subnet mask 255.255.255.240. Okay. All right, and I need to assign an IP address and subnet mask to another interface on the same router. Is it okay for me to use 198.198.79.78?
If you use the subnet mask, yes.
Can I use the same subnet mask?
No.
Why not?
It'll
be in that same range, right, as the other interface. Let's try it. Okay. .78 won't take it. Okay. Can I use the .61? What's that, Roy? Why? And what is the network range? 64 through 79. Let's give it a shot. 61. Okay. Works out fine. What about using .63? Can I use a .63?
No, because it would be
It'd be the broadcast address. Let's see. Wow, it's saying, hey, this IP address is not allowed on this port. Why couldn't we use the 63 again? It's a broadcast address. And how do we know the broadcast address? It's always the highest value in the range. The broadcast address is always the highest value in the range. It's always an odd number. Okay? Let's go back to the interface 0/0. And we said that the 73 value falls in the range of 64 through 79. Can I use the 79 value here?
Well,
No, because again, it's the highest value in the range is the broadcast address. Yes. Right. To get your range, you have to determine how many host bits are available. In this instance, we said there were 4 available, right? Okay. And we do 2 to the whatever host bits are available power. So 2 to the 4th power would give us 16, right? Then what we do is we start with the network address. In this instance, it's .64, and we count 16 values, and we have to consider that 64 is one of those 16 values. Okay, and that's how we get the range of 64 through 79. First of all, how many bits are there in an IP address or subnet mask? 32, right? How many bits were used in this example for network? 28. So if 28 are used for network, then that's easy math. How many are left for hosts? 4. And then we just take how many bits are left, how many host bits there are, and make that the power of 2. So it's going to be 2 to the, in this instance, 4, right? Which would be 16. Okay, now that we know the network address, it's a .64. To figure out the range, basically we're just counting from 1, with 64 being the 1, and going and make sure we have at least 16 values covered. Yep, and you'll get to 69. That'll be your 16th value. Okay. Okay, and then we mentioned in terms of selecting IP addresses from the range, we cannot select the first one, which will be the network address. And we cannot select the last one, which would be the broadcast address. Okay. Let's attempt to assign the network address to this interface. So 198.198.19.64 subnet mask 240, and the router says no. Why does the router say no? Exactly, it's scanning, and it realized that this is the network address. Okay. You cannot put a network address to any machine. Well, you shouldn't. Okay, because we saw earlier, maybe about 2 weeks ago, I attempted to assign the network address to this Windows machine, and Windows put up a prompt saying, "Hey, are you sure you really want to do this?" Okay.
I mean, I thought a machine.
Look at it this way, okay? We said that part of the IP address is equivalent to a street address, right? That's the network address. And part of the address is the equivalent to a house address. That's the host address, okay? And imagine that a packet needs to be delivered, or an envelope needs to be delivered by a mailman. And the only thing on the packet is the street address. Okay, so every house must have not only the street address, but also the actual house address. Okay.
I was trying to think some tips for battery.
Yeah. Jay, we're gonna do some more examples. Okay. Okay, let's AND these values to determine the network address. Okay, I've already converted the IP address to binary and subnet mask to binary. So the next step would be ANDing. All right, I've completed the ANDing process. Now I need to convert the ANDed digits to decimal. And I get 200, 200, 200, 128. David said it's slash. How'd you get 27, David? You just counted all the ones. So slash 27 is the equivalent of what dotted decimal value? Okay, let's see. Okay, here are 8 of the ones, right? So that would be 255, then the next 8, 255, another 8, 255, and then we need how many more to account for? 3. Okay, and what is 224, right? The value would be 128, so 64, 32, be 224. Okay, so slash 27 is the same as 255, 255, 255 dot 224. All right, now here's the tricky part. What is the range for this network? How do we determine the range? What are the steps?
32 minus 27.
Okay, John said 32 minus 27. He's determining that 27 bits were used for network address. So 32 minus 27 leaves us how many? 5 host bits. Then we have to use the formula 2 to the host bits. In this instance, 5 will be what value? 32. So to determine the range, we start with the network address, in this instance, 128, and then count until we reach the value of 32. And we'll find that the range is 128 to 128 to
Wait. You said the highest at the end. Those was even.
159 sounds.
What?
Yeah, 159 sounds good. Yeah. All right. The question is, why are we doing this the old-fashioned way, going through all the nuts and bolts? It's because if we were to use the shortcut that I taught you earlier, and you remember during that time I taught you that, I said it's only good for Class C. If I don't teach you how to do it the long route, you'll be lost when we get to subnetting Class B and Class A. Okay?
So he took their name.
Right, we could have taken the short method with this one. Yeah. Okay, let's do some application here. Let's see if these values cause conflicts. Okay, I'm again at the router interface. I'm going to input 200.200.200.159. And the subnet mask is going to be 224, and what should happen? It rejected because I attempted to assign the broadcast address to the device.
I want to say network.
Okay. What is the network address? 128.
Yes.
And there, it will not take the network address. Which leads me to another point. Okay, we saw that the range consisted of 32 values, right? Okay? But actually, there are only 30 that are usable because we can't use the first one and we can't use the last one. Okay? All right, on the board, we determined in another example that there were 3 host bits available, right? And so we did 2 to the 3rd power, and we saw that the range is 8. How many of those values are actually usable? 6, because we can't use the lowest and we can't use the highest. Okay? All right, I have a question for you. Let's convert /19 to dotted decimal. /19 to dotted decimal. So basically, we're going to start at the left, and we're going to use 19.1. That's 8. That's 16, 17, 18, 19. Now we have to convert it to binary or dotted decimal. No, sorry, convert it to decimal, dotted decimal. What you get, Sam? Okay. We have in the first octet yields 255, second octet 255, third octet is 224 and 0. Okay, so /19 converts to 255, 255, 224.0. Okay. Okay, let's convert /30 to dotted decimal. /30 to dotted decimal. All right, let's say we have a 1, 2, 3, 4, 5, 6, 7, 8. That's 8 of those 31s. 16. Okay, that's 24. Okay. All right, we have to convert the binary to dotted decimal. And we get 255, 255, 255, 252. 252 is produced by adding 128, 64, 32, 16, 8, and 4. All right, John brought up an interesting point. He noticed that this will produce a very small range. So how many available addresses will be found in this range? The range is 4, right? So it's going to be 2 because we're going to lose 2. We can't use the lowest and we can't use the highest. Okay. All right, let's do some ANDing to determine whether or not these two IP addresses are on the same network. So we're comparing 198.198.1.193 to 198.198.1.267. Actually, let me make sure that both of them are using the exact same subnet mask. All right, we notice a pattern here. The 198.255, 198.255, they're the same. Another 198.255, then 1.255, 1.255. So we really shouldn't have to AND those 3 octets because they're the same. The difference will come in the 4th octet. So basically, if we AND the 4th octet, we could simplify the process and finish it real fast. All right? Okay, and after saying that, let's go ahead and convert the binary to decimal. We're trying to determine whether or not those 2 IP addresses and subnet mask combination are part of the same network. Okay, so the first one converts to 198.198.1.192. Okay, and the second one is going to convert to 160, right? Okay, so 198.198.1.160. So are those 2 IP addresses and subnet mask combinations a part of the same network? No, they are not, because this first IP address is a part of the 192 network. The second IP address is a part of the 160 network. So we could assign these two IP addresses to the same router, right? Yep. Okay. What is the range for each of these networks? How many host bits are available?
The first one,
5. 5 host bits are available for both networks. So it's going to be 2 to the 5th power. That's going to produce 32. So the range is 32. But how many of those addresses can we actually assign to devices?
30.
30, right. So what is the range for the 192 address?
192.
192 plus 32 subtract 1. Is that right, Josh? And we get the range of 192 through 223, because it's 192 plus 32 subtract 1. Okay. All right, what's the range for the 160 network? 160 plus 32 is 192 subtract 1 will be 191. So the range is 160 through 191. Okay. If you're still somewhat confused at this stage, that's okay, because this generally takes a few weeks to discuss. Okay. But you would do yourself a benefit if you have taken notes today. When you get home, look at those notes. Look at the notes tomorrow. Look at them throughout the weekend. Because when we come here next week, we'll be starting something else that will build upon this. Okay?
I do have a question.